In this video, we'll look at using the normal calculator in StatCrunch to work some problems. First, we're going to work with a standard normal distribution, which means that the distribution has a mean of 0 and a standard deviation of 1. And we're first going to work some problems where we find probability of area to the left, and then to the right, and then between. So I need to get my tools. I'm going to go ahead and go over to StatCrunch, and I have a blank sheet here. And what I'm going to do is I'm going to go to Stat, back to the calculators, and this time we're going to be using a normal calculator. Okay, so the first problem, I want to find the area to the left, and you notice there's a curve here, and it comes up initially as a standard normal when you pick this calculator with a mean of 0 and a standard deviation of 1, so I don't have to adjust anything here. And I have a z-score. I want to find the probability that the area, or the probability that z is area probability less than z equal to 0.44. So I'm going to put in 0.44 here. Now, in a normal distribution, because it's a continuous distribution, you're only going to have two choices here, either greater than or equal to or less than or equal to. In a continuous distribution, you can't have an area be equal to a single number. Area means you have to have a height times length times width. So you can't have a single number value. So it's always going to be less than or equal to or greater than or equal to. It doesn't matter whether you have an equal there or if you just had a strict inequality. So my answer here for the first one here is 0.6700. Most of the time area probability is reported with 4 decimal places. The one here to the right, we want to switch over and get the area or probability to the right. So I'm going to change the direction here, make it greater than or equal to, and I've got negative, that's really important, negative 1.06, and then I click compute. And so the area to the right of a z-score of negative 1.04 is 0.8554. Now the last one I'm going to show you here is an example between two values. So I'm going to click the between option, and now I'm going to put in the two values I'm interested in. I've got negative 0.84, so I want the probability that the z-score is between negative 0.84 and 1.28. Compute. And I get a probability of 0.6993. Okay, let's turn it around now, and let's say we have the area or probability, and we want to find the z-score that corresponds to it. So I'm going to go back to my standard calculator, and I want to make sure that this is done as less than or equal to, because I'm finding area to the right. Now, I want to find the z-score, so I actually want to find the number that's going to be in this window right here. So in the right-hand window, I'm going to put in the area or probability that I'm interested in, which is 0.8907, compute. Oh. Oh, it has 2 decimals, that's why. Sorry, didn't see that. There we go. And we get a z-score of 1.23. Okay, then I want to find the z-score such that the area or probability to the right is 0.9265. So I've got to change this to greater than or equal to. Over here, I'm going to put in, again, the area or probability. What was it? 9265, compute, and that gives me a z-score of negative 1.45. Okay, now let's change it up a little bit. Let's go down here. And now, instead of having a standard normal, we're going to have a mean and standard deviation. We're looking at IQ scores, and the scores are normally distributed. We call this a non-standard normal distribution with a mean of 100. So I'm going to put that into my mean window, and my standard deviation is 15. And then I'm going to do the problems exactly the same way. Let's make sure this is less than or equal to, because the first one wants to know what's the probability if I randomly selected an adult that their IQ score would be less than or equal to 118. I'm going to put in 118 here, and I'm going to compute. And the other nice thing about this normal calculator is it gives you a picture, it gives you an orientation as to where you are on the curve. Now that we're on a non-standard, I also want to point out here, you can set up the tick marks, if you remember from the empirical rule, 68, 95, 99.7. So this will set up -1 standard deviation, -2, -3, +1, +2, +2, 3 standard deviations. Because unfortunately, one thing this calculator does not do, it does not give you the z-score that corresponds to that particular area. Now let's switch it around, and we want to find the probability that randomly a selected adult has an IQ score of 91 or higher. So I'm going to change this to greater than or equal to. I'm going to put in 91 and compute, and that would be 0.7257. And then again, we have a between option. So we're going to put in the 2 IQ scores we're interested in. This is going to pretty much cover most of the IQ scores here. 79 up to 133. And we're covering 0.9053. Okay, and then again, let's flip it around and let's say we have the area, the probability we want to know what would be the IQ score. So I'm going to go back to the standard, make sure I've got less than or equal to, and I want the area probability to be 0.9918, so that's going to go in here. 9918, compute. It's going to be a pretty high IQ score, about 136. And then I want to find the IQ score that about 15.87% of people have a higher IQ score than that value. So I'm going to change this to greater than or equal to, and I'm going to put in the area probability of 0.1587, and that IQ score is about 115.